Read the following passage and answer the questions. The Doppler effect is the apparent change in the observed frequency of a wave when there is a relative motion between the source producing the wave and the observer. Here all the speeds must be measured relevant to the medium in which wave propagates. Since air is assumed to be at rest relative to the earth normally, the relevant velocities are measured relative to the earth for sound waves. The change in frequency, delta F, observed frequency minus emitted frequency, as a resultant of Doppler effect is known as the Doppler shift. The Doppler effect occurs the electromagnetic wave or electromagnetic waves too, such as light waves or microwaves. If the speeds of the observer and source are very much less than the speed of c of electromagnetic waves, the Doppler effect relationship derived for sound waves could be used for electromagnetic waves by substituting c instead of the speed of sound. The speed of moving vehicle could be determined by measuring the relevant Doppler shift using electromagnetic waves. The instrument used for this purpose is known as a speed trap, which consists of a radar transmitter and a radar receiver. From the transmitter, microwaves are emitted in short pulses and aimed directly to moving car as shown in the figure. The emitted microwaves reflect from the surface of speeding car and return to the receiver of the speed trap. By measuring the resulting Doppler shift, the speed at which the car moves is determined and recorded. In this type of application, used for microwaves has an advantage over the waves because they can penetrate fog, light, rain and smoke. Part A. What is the Doppler effect? We can write Doppler effect. Definition of Doppler effect as given in the paragraph 4 with our words. We can write if there is a relative motion between source and receiver, there is a difference between apparent frequency and real frequency. It is called Doppler effect. Or you can write the sentence in the paragraph. In part B, normally relevant velocities in Doppler effect are measured relative to Earth for sound waves. What is the reason for this? Because of we are considering that the air is at rest relative to Earth. Because of we are considering that the air is at rest relative to Earth. Part C. 1. The radar transmitter emits microwaves of frequency f0. The car shown in the figure 1 approaches the speed up tap at speed u. Write down expression for the frequency f dash of the microwaves received by car in terms of f0, u and c. Considering the transmitter of the speed trap is at stationary source and the car is moving observer. Now, source is at rest. The frequency of emitted wave is f0, velocity c. C means velocity of light, velocity of microwaves in air or in vacuum. Receiver is car, it is moving with a u velocity. Now, we can write the equation. Apparent frequency f dash is velocity of wave relative to receiver divided by velocity of wave relative to source multiplied by real frequency. When considering velocity of wave relative to receiver, we should consider that receiver is at rest, but receiver is moving with u velocity. We have to give an opposite velocity to receiver, and we have to do same thing for the wave. Now, speed of wave is c for this direction. We have given u velocity, then we have in same direction, therefore we have to add c and u. It is the apparent velocity of wave relative to receiver divided by velocity of wave relative to source. Now we have to consider source is at rest, but source is actually at rest. Therefore, we can consider actual velocity c is the apparent velocity of source. Apparent velocity of wave relative to source multiplied by real frequency f naught. It is the answer for part 1. Then part 2. Now the car acts as a moving source emitted microwaves with frequency f dash. Write down an expression for the frequency f double dash of microwaves detected by receiver of the speed step in terms of f dash, u and c. Source is the car. It is moving with u velocity. Source means it is reflecting wave. For the reflected wave, frequency is f dash, this value. The car is reflected, the received frequency by the car. Velocity is same c. It is velocity of microwaves, velocity of electromagnetic waves in vacuum. Oh yeah. Now receiver is speed trap. It is at rest. Then we can get f double dash is the apparent frequency of receiver. Again we have to use this equation, but I will not write this equation again. Velocity of wave relative to receiver. Receiver is at rest. Therefore we can see actual velocity c divided by velocity of wave relative to source. Now source is moving. We have to consider that source is at rest. Therefore we have to give a velocity in opposite direction to source, and we have to do same thing for the wave. Now velocity of wave is in this direction. We have given opposite velocity. Then c minus u is the relative velocity multiplied by f dash. It is the answer for part 2. Then part 3, combining expression obtained c1 and c2 above, derive an expression f dash in terms of f naught, u and c. Now we can substitute f dash value is this one. This part is f dash value. Then we can get f double dash equals c over c minus u multiplied by, we can substitute f dash value as this one, c plus u divided by c multiplied by f naught. We can cancel out c. F double dash equals c plus u divided by c minus u multiplied by f naught. Then part 4, taking u is smaller than c, so that Doppler shift observed in speed step is given by delta f equals f naught 2u divided by c. We have to find the Doppler shift. Doppler shift means delta f. It is given in the paragraph, apparent frequency minus real frequency. Apparent frequency minus emitted frequency. We can substitute apparent frequency is this one, c plus u divided by c minus u multiplied by f naught minus f naught. Now we have to simplify it. Common denominator is C minus U. C minus U divided by C minus U 1. 1 into this term C plus U into F naught minus. Denominator of second term is 1. C minus U divided by 1 C minus U into F naught into C minus U. Now we can simplify it. We can remove brackets in numerator. Delta F equals C into F naught C F naught minus plus U F naught minus C F naught minus into minus plus U F naught divided by denominator is C minus U. Delta F equals, we can cancel out CF naught and minus CF naught. UF naught plus UF naught 2UF naught divided by C minus U. Now, in the question they have given that velocity of vehicle is smaller than velocity of light, velocity of sound, velocity of electromagnetic wave. U is smaller than C. Therefore, we can consider that C minus U approximately equals to C. This is a large value. Minus this one, again this value is the answer. Then delta F equals 2U F naught. We can substitute C minus U as C. This is the answer for part 4. Then part 5, if F naught 3 into 10 to the power 10 hertz and delta S 7000, calculate the speed of U of the car in kilometers per hour. Take C equals 3 into 10 to the power 8 meters per second. We have to substitute values, but finally we have to convert unit to kilometers per hour. Part 5. Delta F value is 7000. 2, we have to find U multiplied by F naught is the real frequency. 3 into 10 to the power 10 divided by C value is 3 into 10 to the power 8. We can cancel out 3 and 3. 10 to the power 8, then 10 to the power 2 in numerator. We can cancel out 10 to the power 2 with 2 zeros in left hand side. Then we can subject U 70 divided by 2, 35 meters per second. It is not the answer. We have to convert it to kilometers per hour. Then we have to convert meters per second to kilometers per hour. I will use basic theory. We can simplify with using 18 and 5. But 35 meters per second means 35 meters divided by 1 second. 35, we have to convert meters to kilometers. When converting meters to kilometers, we have to divide by 1000. Divide by 1 second. We have to convert second to hours. When converting second to hours, we have to divide by 3600 because of 1 hour is 3600 seconds. Then we can simplify it. 35 over 1000 multiplied by 3600. We can cancel out 2 zeros. Divide by 2 5. Divide by 5 2. Divide by 5 7. Divide by 2 18. 7 into 8 56. 5 remaining. 7 into 1 7 plus 5 12. 126 kilometers per hour. Then part D. Suppose the wind is blowing towards the speed trap from the car. Does this affect the speed measurement of the car? Give the reason for your answer. No, because of microwaves. Electromagnetic waves are not depending on the motion of wind. No, microwaves and electromagnetic waves are, the velocity of magnetic waves are, electromagnetic waves are not depending on velocity of wind. Part E. If the speed trap is not aimed directly to the car, but rather than an angle to it. Will the speed of the car measurement be greater, equal or less than value in part C 5 above? Give reason for your answer. It will be less because of when we have to consider components of car speed. I will explain it. Now, car is moving like this. U. Now, wave is moving with an angle. Therefore, we have to consider velocity component of car to this direction. If this angle is theta, we have to consider v cos theta. We know that cos theta value is less than 1. Therefore, we can see a less velocity as the velocity of car. Part F. Now consider the police car with the speed cap moving at speed v. Is chasing behind the car moving with speed u as shown in figure 2. In this situation, the relationship obtained for delta f in part 4 above has to be modified as delta f equals f naught 2 times v minus u over c. They have given an equation. Part 1, determine delta f if v equals 100 kilometers per hour. Use the value of u obtained in part C above. Give your answer to the nearest integer in hertz. Now they have given an equation. We have to substitute on the values. Delta f equals f naught 2 times v minus u divided by c. We have to find the delta f value. F naught is real frequency. It is given in 3 into 10 to the power 10. 2. Velocity of police car is v. We have to substitute in meters per second. We have to get SI unit. Then 100 kilometers per hour. 100 kilometers per hour means 100 kilometers divided by 1 hour. 100, we have to convert kilometers to meters. We have to multiply by 1000. 1 hour is 3600. We can cancel out 2 zeros. Divide by 4, 9. Divide by 4, 25. 250 divided by 9. 25 divided by 9. 2. 18. 7 remaining. 70 divided by 9. 7. 63. 7 remaining. 27.7. Minus velocity of car 35 divided by c value is 3 into 10 to the power 8. We can cancel out 10 to the power 2. 2 into 2 4. 10 to the power 2 100 into 2 200 multiply by minus 10 minus 7 3. 14 minus 7 7. 7.3. There are 2 zeros. 2 into 3 6. 2 into 7 14. We have to separate one decimal place. It is a minus value. Minus 1460 hertz. If you are using kilometers per hour values, we have to substitute c value in kilometers per hour. There is a negative change of frequency. There is a negative doppler shift. It means frequency, apparent frequency is less than real frequency. Part 2, This is F part 1, then F part 2. Explain why delta F less than 0 in this case. The car is moving away. The car is moving away from the source. It means the speed of car is greater than speed of police car. Therefore, we can consider relative motion. Then considering relative motion, the car is moving away from the police car. Part 3. Which method is more accurate to determine the speed of u of the car by considering the Doppler shift obtained C and F above? Justify your answer. Method mentioned in C is the correct method. It means the source is at rest, the speed cap is at rest because of observed Doppler shift is a different value in F part because of there is a relative motion related to this Doppler shift. We can't observe actual velocity of car. It is a relative velocity because of source also moving. Part G. Write down advantage using microwaves in this type of application. They have given in the last part of paragraph. There are advantages. Waves, microwaves are not penetrate fog, light, rain or smoke. We can write it as the answer for part G.